all are T norms. T norm का 4 पॉइंट ये हैं, एक है minimization, एक है algebraic product, एक है bounded product, एक है drastic product. You can get these equations. Get the equation from the book. I'm not telling it because I told it earlier. From the book, chapter 2. Already material has been shared in the Google Classroom. Okay. Once that is done, you have calculated, then you have to plot 3D graph. Okay. You have to plot 3D graph. So far, we have used 2D graph. Means we have used only x-axis and y-axis. Here, what is the scenario? A belongs to x, y belongs to B, and B belongs to y. So what do we have to do? We have to plot a graph like this is x, this is y, then the membership. So this will be 3 dimension. For plotting 3 dimension, what we need? NP dot mesh grid. Mesh grid function does what? Convert 2 dimensions to 3 dimension. Or you can say n dimension to n plus 1 dimension for mapping purpose. That means if I pass NP dot mesh grid x plus y, it will return back x value and y value from 2 dimension to 3 dimensions. Okay. ये वैल्यू सिंगल जाएगा, इसका डबल वैल्यूज आएगा. So it x correspond to y correspond to x, so that it will be easy for plotting. Similarly, we'll also use np dot mesh grid for mu of a and mu of b. Then you will get a 2D value out of it. Once that is done, you have these two and you have to solve what? T norm. So T norm has 4 parameters, so you have to plot 4 different graphs and how they are different from each other. This is what is the task. In order to plot them 3D, so you have to use PLT dot plot underscore surface. It will plot 3D. First parameter is x, second parameter is y, third parameter is mu value. Yes, you can say instead of mu value, you can say T norm value. There are 4 different T norms. You apply 4, it will be visible. I hope you understand the question. Okay. Okay, here I have taken x value and y value both. Let me justify. X value is np dot linspace 0, 10, 100. That means 0 to 10, 100 values. Similarly, y is also same. So take these things into consideration and write the code by looking at the book. This is what is the task. Okay, implement this. I'm leaving 10 minutes. After that, we'll discuss. If you have any queries, you can ask now. Hello, have you got the question?
Yes, sir, but can you explain again what to draw?
Yes. Simply, I say You have X universe and Y universe. And I have given the membership function as well for both. For X, it is Gaussian enough, having X value. You will pass the X value, then this is Y. Okay. Then 4, then 1.5. This is C, this is sigma. Then this is C, this is sigma. You got both the graphs in 2D. Let assume you have set A, the Gaussian MF. The Gaussian MF will look like this for set A. This A, this is X, this is U, A of X. This you can plot if you want to. Similarly, I have given you Y. You can get mu B of Y. This is this. But our job is to find T norms because T norm is giving you A coupled with B, coupled with B. That means what will be our observation? In one axis X, in another axis Y. So with the change of X and Y, how parallelly this graph is changing. For this, what you need? Another axis mu X plus Y. Yes or no? Are you following? What is the change in X and change in Y? How it is impacting the membership? That is what is the observation. By the help of T norm, are you following this much?
Yes, sir.
So this is what is the objective to draw the 3D graph. A coupled B means I have to draw four graphs, four subplots you can say. I have to draw one for each T norm. First one is minimum, simple minimum. It is AB. Second one is algebraic product. Algebraic product. This minimum is known as Mamdani minimum because Mamdani is the scientist who defined this concept. Then it is leap. Then your bounded product or bounded product is bounded product. Look into the equation already given in chapter 2. Then drastic product. That is what is the observation, how they are different from each other. You draw the diagram, then we will continue our next talk. That is what is the task. You are given this, you have to draw three dimensions. For three dimension, I have said one is mesclid function is there, another is PLT dot plot dot surface. If you need more assistance, you can go to internet and find the API. No issues. While working on the corner, you need to refer to APIs for your understanding and documentation. Absolutely. But you need to understand how it works. I hope I have justified your query.
Yes, sir.
Okay, take your time and solve it. I hope everybody is listening and trying to solve. Others, I have expectation from you as well because last time you have also solved. See, if you people are not solving now, it is not fun in learning. By the time it will be more complex, the subject is. Subject is interesting if you practice every day. Sure. ऑफलाइन क्लास में तो पढ़ाई करते हो ऑनलाइन क्लास में नो रिप्लाई नथिंग ओके go ahead and try to solve. We will be discussing after some time. Look, are you trying?
Yes, sir.
Anyone else is trying? Home, others. How much time is required? Look,
Sir, it's done.
sales output. Anyone else? Execute the code. Then
So that is not a algebraic product.
okay. Then others, or you have done only one.
Only this is
You have to find all three. Means rest of the three.
okay, sir.
Take maximum 5 minutes, not more than that.
Okay, okay.
I don't think 5 minutes is required. 2 3 minutes is good.
Mm-hmm. You have the equation.
Yes, yes. Go ahead and do it. Does that just give this away? Share screen. Okay. We have to find out all the. We have gone through all set of product. has four segments. The first one, this one is your main product. Then this one is your algebraic product. Then it is bounded product. This is drastic product. But the name already given differently. The reason is these equations are defined by those scientists. Main or minimum is defined by Mamdani. Product or algebraic product is defined by lesson, and your bounded product is defined by locativity, and drastic product is not mentioned by defined by whom. Why I'm mentioning the name in future, we'll be seeing many things from Mamdani. Mamdani is a very good scientist and defined many fuzzy logic inferences, more fuzzy inference systems, fuzzy implications, many things have been implemented by him. So that's why those mentions. Okay. So you can compare how, if I'm taking minimum out of A and B, how the value is expanding over the x-axis and y-axis, and how membership grade is gradually expanded over the space. In case of product, if you see, it is more like spike, less expanded. And in case of bounded product, there is a bound as per the equation. Let's look into the equation. There are four methods. One is minimum, then your algebraic product, then your bounded product. Bounded product is either zero or this value, maximized value. So bounded product is like this. Then drastic product, I think you have seen the examples in equations. I no need to explain the equation. If it is the requirement, you can go back to chapter 2 and cross check. Okay. Then the visualization part. If you have any doubt in the encoding part, you can ask me. Otherwise, I think Alok has done it. Let me do one thing. Let me put this code in the Zoom chat so that you can try it by yourself. This is part one. Then the visualization part. Okay. Okay. That is also mentioned. I've shared two of the parts. You can cross check, take 2 to 3 minutes and copy it and test it and execute it. Okay. Then we will continue with next phase of implication. Implication are of two types. One is coupled, another is entails. So we'll be looking at entails after 2 minutes. Okay. Hello, I think your code and my code are more or less similar.
Yes, sir.
You understood the code, right?
Yes.
Okay. Okay, let's start the second topic, that is A entails B. A entails B is little different as compared to your A coupled with B. Coupled with B is your, what I can say, T norm between A and B, which is easy to calculate. Even this one is also easy to calculate. Let's take the example. I'll write down the formula for this. There are four formulas as well here. Number one is material implication. Number two, propositional calculus. Number three, extended propositional calculus. Number four, generalized modus modus ponens. Okay. Okay. Let me write down the equations. This is the relation where A implies B is denoted as negation of A union of B. This is also the relation of this is R. All are implications. Okay. B, where it is denoted as negation of A union A intersection of B. This is also the relation R. Which implies A implies B, which is denoted as so for three, the equation is negation of A union negation of B, so intersection union with B. The fourth one is modus ponens rule, which is shape of second right R is equal to A implies B can be denoted as, you have to identify mu of R of X comma 1. Right. How I can write says sweep of C. Where C is what? Mu of A of X in order with C, which is less than mu B of Y. Okay? And C is nothing but a value between 0 to 1. 0 to 1. Okay? In this case, where you can say A implies B is a T norm operator. It's like coupled. Okay, these are the four formulas. Out of which, look at these three formulas. Okay, look at this one, two, three formulas. Third one is written here. Make a note of it. Then we'll analyze. Either you take a screenshot or note it down. Okay, I hope you have noted down. Let us have a universe X or universe X and Y both denotes to the same space if this area, this area is set A, this area is set B. That means I can write from the universe this A and this is B. Then identify and mark the zone which belongs to equation 1, equation 2, the equation 3. For equation 1, you have to identify. Then for equation 2, same diagram, you have to identify the zone. Which zone will be selected. Okay. This is a similar diagram. So let's take few minutes and analyze this. This is set A, set B. Hello, have you understood the question? What I'm asking here?
Sir, can you explain again?
Yes, I have. Forget about the fourth one, we'll be discussing later. Let's focus on first three equations. These are the equations, right? 1, 2, and 3. Those are sets. If I say from the universe, this zone is my set A, so negation of set A will be other part. Similarly, this zone is set B. Okay. Then you find out for the equation 1. What is the equation 1? Equation 1 is negation of A union with B. You have to find out here what zone will be colored or marked. Similarly, for the second question, and second equation, what will be the zone? You have to identify here. Similarly, for the third, what will be the zone? You have to identify here. So take 5 minutes and analyze and draw the diagram. Then we will discuss. Okay. That's what is I asked. Put in the equation part, zoom out a little bit. Then this can be visible. This is what I want. Okay. Understood? Hello, have you got the answer for all of them?
So,
Okay. Let me solve one. You say whether it is correct according to you or means you got it or not. The first one is negation of A, union of B. Let's understand. Uh, if this region is A, negation of A is this, 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 right? Then question is asking negation of A, union of B. What is union of B? B area is this, this. Right? Are you following?
yes, sir.
This will be the outcome. Yes or no?
Yes, sir.
Or anything else will be that. Observant. We got this or not? So this area would be the answer. What is about the second one? Second one is negation of A union A intersection B. Okay, let me write down. Negation of A union A intersection B. This is A, this is B, this is A, this is B, and A intersection. So A first is negation. This area is negation. This area is negation. I have taken union with A intersection B. A intersection B will be this area. So the answer will be this area along with this area. Right? Let's come to the third one. Third one is what? Third one is negation of A. Negation of A and intersection of negation of B, whole union of B, negation of A is this one. Then negation of B is this one. इन दोनों का intersection one common point. So I have to remove these 2 points. One, then union with B. So this again, this and this. So if you observe, all three having same output. Yes or no?
Yes, sir.
So this is what is the understanding. If I find implication of A implies B, whatever is the formula I will apply, I will get the same result. Formula are the different way of representing the data, but at the end we are getting same values. Understood by everyone? Right. Any queries out of it? I hope there is no more query of this.
Yes, sir.
It is simple. There is the basic concepts. I have enough time. Section से जहाँ हमारा एक क्लास पीछे चल रहा है, let me try to balance it out so that next class onwards it will be easy. What do you think about it? That will be right, better, right?
Yes, sir.
This parallel चलने से mentally I will be in the same page for everyone. Let's go to the book. The screen is visible, book is visible.
Yes.
We have studied this one. Just giving a brief idea. We have started with this, taken the example. I will give the same example as it is. You can think of any other example where both the part are positive. With those kind of scenario, we can implement. One method is A coupled with B, where we are using T-norm, and another is A entails B, where we are using these methods. Okay. So, fuzzy implication is nothing but the relation between mu A of X and mu A B of Y. We have already studied little bit of in the second chapter when we try to inherit or so when we try to introduce 2D image, right? Then comes your coupled का formula ये है. It is T-norm, already explained, and you have also implemented this. I just showing what is there in the book. So it has taken, instead of we have taken Gaussian enough, it has taken Bell enough over here and tried to implement this in the graph. Okay. Then comes fuzzy reason. It says, in order to do reasoning means what? Analyzing, and inference means deducing some result out of it. So from that, if I say I have X from A, means from set A, let's say from set A I have X, whose membership value is mu A of X. And if I have some value f of x, already we know this, I implement this on f of x, I will get y. And once I get y, I can get the value of mu A of x. This is what is the understanding. So, if you go ahead and read this, how this composition works, you will be able to understand how we can generate B. What is B and what is A? X is a general term. Let's say A is a specific term out of those general terms. If I take a graph, X is the dimension out of which any point A is a A. And if I know the f of x, let's say this is f of x, which will give me y. So if at A I will draw the perpendicular, I'll intersect it, and I'll again draw the perpendicular to the y axis, I'll get the y value. This is what is the concept. If my A value is a singular value, I'll get like this. If A value is an interval, I'll get an interval value. It's a D. Why? When it will be interval? When it is a 2D MF, I will be having projections. When the projection concept will come, what I'm saying is these are the cylindrical extension of f of x and a. Then the extension will give an interval value. Let me go to the diagram and explain over here. This is for singular value x equal to a, then I'll get y equal to b, and this is the cylindrical extension of it. If it is the extension, there will be a region. Okay, there will be region. Okay, for that reason, if a is known, I can plot the parameter that will get the b result as a calculation. This is what is the understanding. That means this is mu c. Mu c is what? Cylindrical expansion over the whole f of x y means a implies b. Then how I will calculate? I'll calculate using the formula minimum of cylindrical extension of a along between. Why I'm not writing minimum? As I am calculating intersection, the common between them, intersection is denoted as mean value. So I can calculate mean value. Again, this mu c of x, cylindrical extension is what? The cylindrical extension is nothing but the mu a of x. The cylindrical extension is what? Nothing but the mu a of x. So I'm finding the minimum between these two. Are you getting? Hello?
Yes, sir.
Okay. So if I have to calculate mu b of y by projecting this calculation onto y-axis, how I will get? If you go to composition principle, same principle, how I will calculate max mean composition mu a of x versus mu a of x onto the relation. Here the relation R is denoted by f of x comma y. So मैक्सिमम कंपोजिशन होगा तो क्या होगा? इन दोनों के बीच में मिनिमम निकलेगा, उसका मैक्सिमम निकलेगा. These two data are there now. One is a value, another is f of x. So we'll apply this. Mu a of x is nothing but a vector, and it's a matrix. So this vector will cross. We can write 1 cross n, and here m cross n. The answer will be 1 cross n, which will be mu b1. This can be broadly represented as a composition between b equal to a cross r over f. This is what is the formula. This is a binary composition, binary relation. Here we are applying maximum composition. Instead of maximum composition, any other composition we have studied?
Max product.
Very. Here, the basic one is we are using maximum composition. Okay. So let me do one thing. You can take a screenshot of it and analyze it. Are you connected with the laptop? You are studying from the laptop, right?
Yes, sir.
Better take the screenshot of this paragraph. Let me delete this part. It will be easy to do. right? Yes. Take a screenshot of it. Oh, this is done.
Yes, sir.
Don't worry, after the end of the chapter, I'll be sharing the chapter as well. Then take the screenshot of this chapter, this part also. So this will help you. This will help you understand the topic in a much deeper way if you read it twice or thrice. Yeah. Then we will talk about for the reasoning. Reasoning something. See, I've taken the example earlier that tomato is green, then it's ripe. Okay. This is the rule you get. This rule, if you take into consideration, you went to a shop, vegetable shop. Then you started observing the tomato. This is not position. This is so. This is not fish because you will say either the tomato is red or the tomato is not red. Here we look at the tomato, then we started analyzing how much red it is. Yes or no?
Yes, sir.
Okay. Now, based on the gradation of the redness, our brain figure out how much ripe it is. So basically, we don't need this ripe is also present. And secondly, we don't need the extreme ripe vegetable. What we exactly need, if it is not so red, if it is not so red, we need not much ripe value. That means the rule is given for right, but we are looking at the negation of it. If red is set A, right is set B, we know A, we can map to B by the formula of f of x. But what we are requiring, we need negation of B. So we need to figure out how to get the negation of B. Okay, this is what is the target. So if I know A and A dash, then I can map something A to A dash. Then if I from A, I can get B. Then from A dash, I will generate with combination of B. I'll generate B dash. Are you following my point?
Yes,
Let's
sir.
take this. Let's take this example over here. That's given how we analyze things. The fact that the input is given is like input is X belongs to A. But the rule says if X is A, then Y is B. Input goes to the rule, then you get the output. Similarly, if you observe this, if tomato is red, then right, then I can say tomato is more or less red. Then we can say tomato is more or less ripe. Similarly, this negation will come. The fact is X belongs to negation of A. That means more or less, or dilation, or concentration. You can apply any method. Now I'm giving you an example over here. If X is negation of A or A dash, then rule says if X belongs to A, then Y belongs to B. That means if it is A dash, then it will be belong to B dash. Yes or no? समझ में आ रहा है this part? You can give it a read and analyze. Are you following?
Yes, sir.
Okay. Let's look into. I'm not explaining it here. You can apply the maximum composition and you'll get B dash. If you look into the formula, X is A, your R is given, then how you get, if you, already we discussed this formula, right? Above here, we have discussed the formula, maximum composition. For B dash, what I have to do? I have to go for A dash, right? This is what is the implication. अरे B के लिए मुझे अगर निकालना पड़ता है A and let's say I'll write maximum between A and R, then B dash के लिए A dash करना पड़ेगा. Yes or no? This much is the concept because the relation will not change. Relation means this is rule. Rule will not change. So applying rule to the negation, I'll get the negation. Are you following?
Yes, sir.
Let's understand single rule with single antecedent. What is antecedent? If A implies B is given, this is antecedent or fact what is available, and we have to conclude. And what is a rule? Rule means how it is implicated, which line. So if I know the implication rule and antecedent, I can predict the conclusion. This is what is the question. This topic here. Single rule with single antecedent. Hence, if this is the case, A implies B is given, how to calculate B dash? Applying maximum composition, you will get this. Then intersection with B. Then you will get B dash. This will give you B dash as the formula. So how it will be done? Let me give you graphical notation here. That will be more appropriate. Let us assume you have set A. You have set A. Then we will calculate set B. If you are thinking why A dash, so A dash, why it is overlapping? For example, let's take tomato. If red may be the parameter of this. If I say red is A, if I say negation of A, is it completely not red? No, because it is not crisp. Crisp में क्या होता है? Either red होगा और नहीं. इसमें क्या होगा? Membership होगा. So some part of negation will overlap with A. Are you following? Are you following here?
Yes, sir.
Now, whatever is the common point, what is the maximum grade is the threshold or firing strength of this calculation. If I map this to, this is the max part, and I'll take the minimum value here. Now, if I intersect this with B, we get the negation of B. This much will be the negation of B. So, if you want to draw, you can draw a diagram of B, something like overlapping with this, but like this. Okay, this is called single rule with single antecedent. हमारे पास एक ही रूल था. जब मल्टीपल रूल आएगा तो क्या करेंगे? Let's go to the diagram. Don't worry about explanation. Coding. If I have set A, then negation of A. I have set A and negation of A. Similarly, set B and negation of B. Whatever will be the minimum out of it between these two weightages, that will be considered to the C. That means if I say if X is A and Y is B, then Z is C. Here, this is the rule. And fact is this one and this one. And prediction is this one. You have single rule, but antecedent कितने हैं? दो हैं. Conclusion कितना है? एक. Okay, up to this we have covered in your other sections. Sharing these things. In between that, if you want, you can also implement your implications. coupled वाला implement हो गया, implication को भी implement कर सकते हो. Okay, coupled वाला हो गया था, implication को भी implement कर सकते हो. Implication which one? These four rules you can implement. Cross check how then. Analyze any part you are not getting, you let me know. What I have said here, single rule with single antecedent is like if I have A, if I have A is like this, and I have to calculate B, which is given like this. I have to find out what is B dash. Then I have to observe what is A dash. Let this is A, this is A dash. I have a common region like this. In this region, this is the max peak, out of which I will take a straight line here. We give a alpha chord at set B. This chord will help me find out or project to B set to B dash. I can say this will be the B dash. This is B dash, which is calculated out of A dash. Okay. So I can write A mu A of X intersection mu A dash of X. Anyway, B. This is what is the equation. Who got from the book? Okay. This is not union. This is again intersection because this will be again common. This is not union. Union honestly extra add over. So this is also intersection. So this intersection will give you this peak. From this intersection, from this and this, you will get this. Understood? Understood or not?
Yes, sir.
Then we have explained single rule with multiple antecedent, where I have taken two input. One is A, this is addition of A. Then I have taken B, B. Then we have taken C. So we'll take this point, and take a plot over here, take this point, take a plot over here. Whatever is maximum, it will take. Okay. This is A, B, B dash, C, then this part is C dash. This is how you calculate single rule with multiple antecedent. We have discussed in the other sections up to this much. I want you to implement this at home so that we don't waste time. Coupled wala ho gaya tha, so you implement the which one? Materialistic implication, propositional calculus, and extended propositional calculus and generalized modus bonus. At home, we'll see and discuss tomorrow. Any queries? Any doubt? You can ask. I'm keeping the meeting open. If you have any queries, you can put it in the chat. Otherwise, after 5 minutes, we'll wind it up. Om, are you telling anything?
নমস্কার।
Are you getting the concept?
ছাড়বে না তা তো ছাড়বে না ছাড়বে না এগুলো ছাড়ো লিঙ্ক পাঠিয়ে দেবো আমারটা কমে ছাড়বে না রে এটা আল্লাহ আমাদের মনে হলে সর্ব প্লাস্টিকের এলো ফাটলা খাইব খায় না রে এটা বললো না ওটা কত বড় লাগে ফাটলা না করবে ছাড়ি শুধু খান বললো না হ্যাঁ খাইবা ফটো দেখা পাশে আনি আনি করে মানে পানি বড় মোটা তার দেওয়া ভালো লাগে তার কোন বড় বড় তারপর দিতেছি রেটা নেই সাড়ে সাড়ে দিলে কম করতাম তো রেটা দিচ্ছে তার আগে মামু বলে রেস্টুরেন্ট দে যে রেস্টুরেন্ট দেবো তুই বকুল বকুল ডাকবো বলে সেই মত পড়তে যাবো মামু বলে ডাকবি না আমার কই মোটে কই খাল খাল খাও ডাক